Thank you for being here today. Today we're talking about empowering websites with SaaS integrations. So I'm sure many of you are aware that SaaS stands for Software as a Service, and many businesses will have some sort of SaaS platform that they're using to run their business. And today's talk can apply to any other API that you want to connect to. So it's basically your website. Traditionally, you have a marketing website that has maybe 5 pages on it, and you put some information out there, and that's your website. Maybe you expand it with more pages, and then maybe you add in a few plugins and you add some more things there. And what we're talking about here is that by using APIs to connect to other systems, you can pull in real-time data from other systems to be able to create a better experience in that website, giving it more capabilities. So this can connect to any of the purposes that you may have. So as we go through this today, just kind of think through the maybe projects you may be working on or applications you may have, the systems that you're using. I've tried keeping this broad so that whatever CMS you're familiar with and that you want to use, you can really apply these to any CMS that you're using and to any of the applications that you want to be able to connect to. And really what I'm trying to give you today is the building blocks to be able to make this happen for your purposes. Today we're walking through a scenario. You're a website agency hired to build a new website for the fictitious national pet store chain PetMart. You're excited about the opportunity to build a site for a 300-store chain that also has an online store. So we're going through the scenario of just seeing, as we go through and learn about this website that they want us to build, how do we tackle these scenarios using APIs to connect to a system to be able to meet things for the project. So as we start the discovery, we learn a few things. They're looking for an e-commerce store that they have several thousand products. So all of their individual stores, they want to be able to take those products they have in the stores and put it on the website. That makes sense. But if you think of this as like a traditional marketing website where it's like 3,000 products, I have to maintain that. That's really hard. That's a lot of things to maintain to be able to maintain 3,000 basically pages worth of content on that site. So that's going to be a lot of work. And then you need listings for each brick and mortar location nationwide. So again, thinking 300 pages, that's a lot of pages to be able to maintain manually for all these locations. And then each of these locations has individual services that may vary between location because each location has different services. They may not offer the same thing as everyone else. So now you've got to maintain all the pages. You can't just kind of cut and paste all the different things. You've got to be able to maintain this data for all 300 locations. So again, lots of manual work to be able to maintain this. The next requirement that they ask you is that the online orders need to integrate with a fulfillment system so the warehouse can fill the orders and the inventory levels online stay in sync with actual warehouse levels for out-of-stock messaging. So I'm sure you've been online and you've seen, oh, that product I wanted to order is out of stock. That's helpful for you. It's helpful for the business because they're not selling orders to products they can't supply a product for. So they want to have that capability so it makes a better customer experience and it helps them be able to manage their business. So we want to be able to get that information, but not from that traditional mindset. If that's all we've ever built, how am I going to do that, right? So what do we do to be able to get that information there so that we can have that requirement that you can look at Amazon, and that seems to be a normal way of business for someone like Amazon. And then at each location, we want to have up-to-date listings of the available pets in the store. So now, as you're looking at the pets, you can browse online to see the different pets that are available at this location. You might find the one you're like, oh, let me go into the store and check out that particular pet that you fall in love with, and you purchase it. So you want to be able to have what's available online match what's in store. But now it's a lot of manual entry. And how many pets per store again? And then the next one is when a pet is sold in store, the website is instantly updated. So the reason behind that is that if something is sold in store, you want to be able to have the website take that pet from no longer being available online, so you're not having people come in the store looking for something that sold 2 weeks ago. That would be a really bad customer experience. So we want to be able to do that. But you're thinking to yourself, I have no idea how that's going to happen. So the next one is each location have a search of available pets. I think I can do this, but not sure. And then the products online show whether the product is in stock at your local store and even which aisles it's in. And I'm sure you've seen this. You're in store, you're looking for a product, you can't figure out where it is. You look up it online, and it says it's an aisle E. It's an aisle E halfway down. So you find out exactly where it's at. You can find your product. But we also want to know: is this a product that's only available online, or do they have it in store? And is it in stock? So we want to be able to keep that in-sync data. But now we really don't know how that's going to happen. How do we know what all the stores have for all their products? It's just a lot of information. Just manual data is just not going to be able to do it. It's not something that we can do. So let's keep going with our discovery. So you start asking questions, and you discover that they have an internal SaaS platform that everyone lives in, and is always up to date with the data. So as they have all those stores are running off of a platform that's keeping that data up to date. And you're like, okay, great. You realize that if you plug into that system, then you can meet all the requirements. So that system has the information you need. And what are the advantages of that? The data is not siloed into two separate systems. And then you don't have to worry about manual entry into both systems, because one system's automatically maintained by various processes. And you basically, on your website, you're just presenting the work that's already been done in the other system. And then you don't have to worry about data getting out of sync or miscommunication from someone looking at outdated information. So going back to the pet that was sold 2 weeks ago, you're not having people come in looking for something that's in the wrong place, or if you're looking for what aisle something's in, we rearrange the store, and that's over in aisle C now. So you have all sorts of things where the data's just, it's all in sync and it's always up to date, and you create a much more powerful website and a much better experience for your customers. So let's move into planning. So for this project, you're using an open source CMS and a plugin for the e-commerce. The concepts here can be applied to any major CMS, so think of everything that follows in terms of the platforms you're familiar with and how you'd apply this. I'm giving you Legos as building blocks to apply to the tools and platforms you're already familiar with. These Legos can be used to connect your website to the API applications you need for your projects. So basically, I really loved playing with Legos as a kid. So what I'm giving you is, like, you can take all those little Legos and you put them together to make something really cool. So as a kid, I would just imagine what I need to want to build, and I find the Lego pieces to be able to build what I need to. So the same thing is here. We're going to take a look at those individual pieces and then figure out how we put those individual pieces together to create a whole system to meet those requirements. So let's keep going on the first major decision. So is there a pre-built plugin or integration platform for their Pet Manager SaaS? So a lot of this decision, as you're connecting to some other system, you need to be able to see, is there something that already exists to connect to that system or to be able to bridge that gap? And if something already exists, I don't have to reinvent the wheel, right? So if it already exists, I'm going to save myself a lot of work, and that developer who made that plugin or whatever would have already done all the hard work of fixing all the bugs that I would have made on my first time through. So we find something that already exists to make it a lot easier. You start with a plugin. Here we find for this product that there's iPaaS, which is an integration platform as a service. So it's an integration platform that has a pre-built package is one other way. So whether it's a pre-built plugin or an integration platform that bridges that gap for you. And in this particular scenario, we find out that this pre-built solution can integrate products. So when a product is created or updated in the Pet Manager platform, it sends all that data up to the website, and voila, the work is done. You don't have to create it up there too. It's already synchronized. All the data is in sync. This also integrates the inventory levels. So now we just fixed our out-of-stock issue. It automatically knows what the in-stock level is and whether it's out of stock. And if a new shipment comes in, and inventory levels online are increased as the new inventory is available. And it syncs customers and orders. So as new customers are created and new orders are placed, that brings it down to Pet Manager. So it keeps that into sync. And then when fulfillments are done, it can go ahead and the warehouse shows the fulfillment, and then tracking information can be sent to the website to be able to keep those systems in sync and create a great customer experience in an e-commerce store. The downside, though, is that Pet Manager doesn't have a pre-built plugin for your open source platform for all the features that we need. So with all those requirements that I outlined at the beginning, we don't have solutions for them out of the box. We're going to have to do some work to solve the problem. So this means we'll have to build many things ourselves. So here we're looking at an iPaaS stack. So this is just the technical stack. So if you look at the website at the top, Pet Manager at the bottom, how do we get between those two systems? So there's a few things in between. We've got a database that's storing some information. You've got a REST API. You've got a hosting platform that is hosting the website. You've got your iPaaS in the center at the purple level, and then the Pet Manager API. And you'll notice that the iPaaS in the middle is the bridge between the REST API that connects to the website and the Pet Manager API, and it creates that bridge between the two systems. So as you're building, it's just helpful to figure out, okay, this is the bridge in the middle, and this is how it's connecting both things. So you would just need to know that you're connecting. You'll need to understand how the API on one side works, and you'll need to understand how the API on the other side works, and you create mappings in between to be able to connect the two systems. So you'll need to understand the API on both sides. The other stack that we'll use today is a cron job stack. And what this does is, you'll notice in the green, there's a middleware that will have some basic code for a PHP level that bridges the gap to the Pet Manager API. So this is the middleware, brings the data from the Pet Manager API into the website database for presentation on the website layer. And then another one that we're going to look at is a webhook, and this is going to help us with the real-time data. So you'll notice that at the bottom we have Pet Manager, and just above it is the Pet Manager webhook API. And what happens is that if some event happens in Pet Manager, in our case, when a pet is sold, for example, that pet is now no longer available, you can trigger a webhook that sends a message up to the REST API in green that can then store that into the database so that that is now available for the next time someone goes to the website. The page is loaded with that new information. It's no longer showing that pet is available because that webhook informed the site immediately once that transaction happens at the register. Pet Manager is updated, and it sends that webhook to inform the website it's no longer available. So let's take a look at our initial plans as we approach this. So we looked at the iPaaS solution for the e-commerce. So we're going to use iPaaS, which is the integration platform as a service for the e-commerce integration. That'll be the backbone of how we build things, but we're still going to need to build out a lot of the other solutions along the way. So for the brick and mortar locations and services, we can maintain those by cron jobs, connecting to the Pet Manager, and then pulling the needed data into the website's database. And then for the product in-stock status and aisle for each location, we can pull that into Pet Manager, and we can also use cron jobs, but we're going to pull that into a 1-hour schedule, which is going to be a little bit faster than locations. Locations change a lot more slowly than in-stock status. So we'll pull that on a 1-hour schedule. And then the pet data, we'll pull that from Pet Manager using cron jobs as the main backbone of that communication. But then we're also going to pair that up with webhooks to be able to keep that with real-time information for when there's a new one that's available, it's instantly shown online. And if it's sold, that way it's up to date, keeping that data maintained. So we're actually leveraging two methods of keeping that data up to date for the pets. So let's look at our API building blocks. And here we're really looking at what are these Lego blocks. And they may seem simple if you're an advanced developer, but what I really want you to think about is how can I take these very simple things and build something really cool with it? So you've got some project you're working on, you've got some system that you already have in mind, you've got these different things, and it's like, how can I take these building blocks and apply it to my situation? So they may appear simple on the first pass, but they actually end up being very powerful tools that are really the backbone of much of the processes of the internet today. So let's start with the anatomy of an API request. So it starts with a method. Here I've just got an example of get, but there's also post and put. There's a URL. Here I've got, we're connecting to the Pet Manager system. We're looking at the API. This one is versioned with a 2025-10 release of the versioning of this endpoint, and it's looking at pulling pets. And you're also going to have some headers. In this case here, you're going to define a content type. This would usually be used with a post command with a content type. You're saying that the format is JSON, and then you're going to use an authorization token to secure the request and show that you're an authorized connection. And then for post and put requests, you're going to use a body. I've just got simple JSON here, so just you use a JSON payload if you're sending information. But also as you're receiving information, you're going to see something like this being sent back in response. You're going to have a body that's going to be in JSON format. So the HTTP methods, there's get, post, and put. Each of them typically will have a certain function. So get is usually a read, post is usually a create, put is usually an update. And then the response codes are related to that. Usually you're going to get a 200, or for post, there's also 2-1 created, showing you that your request is successful. These response codes are important because as you're sending a request or receiving a request, you want to know that that request was either received correctly and that you're receiving a proper response, or if there's a failure and now you have to handle a failure. So these response codes are very important in working with APIs to know that you're getting the expected results. So another thing that I think you can oftentimes be tempted to underestimate is the platform documentation. I think we take it for granted, but it is an invaluable resource to let you know many good things. It helps you know how to connect and lets you know what endpoints are available. It lets you know what the request and response formats are like, and it lets you see examples of responses, requests and responses. So as you look at the platform documentation, it's going to tell you everything you need to know to be able to build out that connection. So as you're like, okay, how do I do this? That's going to tell you how to do most of your work. So it's your guide to know how to do most of your work to be able to connect to the platform. So as you're looking at what endpoints are available to me, as you're trying to figure out what are my building blocks, these are some of your building blocks. It's going to tell you what endpoints are available to me, what format is available to me, what fields are available in this thing as I'm connecting to it, what are the fields that are available, and what am I going to be able to get back out of the system as you're communicating back and forth, because you've got this external system and you need to know what data is available and what you can send to it. So any way you're trying to work with an external system, that documentation is going to be your guide. So let's look at some PHP. This is some sample code of how you'd send just a basic curl request. This is for a simple GET request. So in this example, we've got a URL that we're reaching out to pets. So this is just a simple, I'm getting all pets in the system. And I've got an API token, and I've got that set to a variable. I've got some headers. I've set it to accept, which means that I want my format of what I'm receiving sent back in a JSON format. And I'm using an authorization token. That way I can connect and it'll give me a response. And then I do curl init to open up a curl session. I set my URL under curl option URL to set the URL that I want to send this to. And then I do the curl opt return transfer true to say that I want to be able to have a string response. In this case, because I've defined the response type as JSON, it's going to give me a JSON response. And then I apply the header, and then I execute the request. And if you'll notice that took very few lines to be able to connect to an external system. When you really boil it down, it is just a few lines to be able to get to this external system and be able to make the request. And you normally, I have just a little bit of information in here that if there's an error, I just have echo handle request. But you want to handle an error if there's some sort of error with that request. And then you close the connection. Here I have echo response, which is just print on screen whatever came through it. So during development, that's useful if you're trying to, I've got a response back, what does it look like? That's probably step one in development of just getting it on the screen. It's like, hooray, I got a response. And you're kind of like your first little thing, but we need to go a little bit further than that. We need to parse the API response. So if we get back a JSON response, we need to work with that JSON response and do something with it. So this next little bit, we'll go through and show you how to do that. So in PHP, you'd use JSON decode and pass in the response with true as a parameter, and then you can set that to data. And what that does is it creates an associative array of all the data that was in that JSON response, and now you can work with it as an associative array. Oftentimes, you may have multi-level JSON because JSON can be very nested. You can have multiple layers of data. You can have arrays inside of it. So We'll talk through how to work through that, but the first thing we'd want to do before we start working with that data is we pull the HTTP code out of that request. So I use curl get info, I get the HTTP code, and then there's this if statement confirming that I've got a tuna response. So as we looked at the thing at an earlier slide where we talked about looking at the 200 OK success response, you want to know that you've got a good response before you start parsing the data. Otherwise, it throws an error and it'll end up being a failure. And then it's oftentimes helpful to be able to check and see that you've got data as well. So you're really checking to see that you've not only got a successful response, but you're actually getting data back as well. And in this response, I'm anticipating having a data ID, which is just a one-level response on this. In red, I have the data that I'm expecting to receive. Here I'm only setting data ID to ID and name to equal to data name. And then I have an else statement so that if it didn't meet that criteria of a successful response and it didn't have data, there's unexpected response or missing ID, you'd want to have something to handle that scenario so you don't have a complete failure. You want to handle errors gracefully in your system. So just to summarize what we're looking at here, you convert the JSON to an associative array, you verify successful response code, and then you do what you need to with the data. So I highlighted in red how to access the data at a very simple level. This would basically be a response that has just one level with ID and name. You could have more data in there. It's very simple on this example, but it really is going to end up being based on the structure of the JSON you receive. So when you look at the documentation, you'll know what the format's going to be that you're going to get back, or if you're not sure what you're getting back, the previous slide where I said echo response, you'll know what your response is going to look like, and you just basically work with whatever response you have to be able to structure the data based on that response. And then if you have an array inside of the JSON, you also probably have to loop through the data. So if you're receiving location, so this here actually is and the previous slide was pets, you probably get an array of pets as your response. You'd want to loop through all the pets that are on there, so you do a for loop of length of the array to be able to loop through all the pets that are received, and then you do whatever you need to, whether you're inserting them into the database, you're updating them, or you're extracting some sort of information for some purpose, that you'd loop through that data using a for loop. So once you have the data in the format you want to use, you can perform whatever desired action you want to do with it, and then you can save it into the database or do whatever you need to. Another thing that is going to be really helpful is understanding OAuth 2.0 connections. So OAuth is just a standard for connections. So a lot of systems, to be able to connect securely, you're going to use OAuth. There are other methods available, but this is just a typical one. So I picked this one just so you're familiar with a typical connection type. So it's a multi-step process to obtain an access token to make your requests. Before you begin, you'd register your app with the connecting system. So in our example today, it'd be Pet Manager. You'd register the app, you'd get a client ID and secret, and then you'd store that in a secrets manager on the web server that you'd want to be able to connect. So you'd use that client ID and secret to get an authorization code. That's step one. And then in response, you'd get an authorization code. And it's a multi-step process, so that authorization code alone isn't going to give you access to the system. It's only a temporary authorization code. So you'd send a new request to exchange the authorization code for an access token, and then you'll receive the access token. And then step number 5 is you can use that access token to make your request. So it's a few steps to get into the access token that you want to use, but that's the process that you'd follow to be able to connect to an OAuth 2 connection. It may vary based on the platform you're connecting to, because they may have a few variants for their particular platform that they're connecting to. You also want to look at the documentation of the system you're connecting to, because sometimes they'll have an API, they'll have a library that you can plug into. So if you're using PHP, you want to get the PHP library for their SDK to plug into the connection, where you basically call a function and you can get your token because it manages everything for you, because you've loaded the SDK into the right things to be able to make your connection. So leverage the tools and things that are already available to you rather than having to write the code to necessarily handle this if something already exists to do all the heavy lifting for you. So the next thing is we're going to take a look at cron. Cron is a Linux-based scheduler that can run automated tasks. So cron jobs are stored in a file called cron tab, and the schedule uses 5 units of time in the following format, which is minute, hour, day, month, day of week, and then each field can use a number or a wild card, which is an asterisk symbol. So for example, if we wanted to do every 15 minutes, let's say we want to have some cron job run every 15 minutes, we would do */15 and then stars for the rest of the numbers. This would make that cron job run every 15 minutes to do whatever action we wanted to. So in the example of Pet Manager, if we wanted to pull pets every 15 minutes to see recent changes, then we could pull pets every 15 minutes to really have a close sync on that data. If that was a piece of information that we thought there's going to be enough velocity of change where we really need to keep that data really up to date. And then you'd also want to make sure that the process can finish within that 15-minute window as well. So let's look at the implementation. So this may vary slightly based on your CMS, but the principles are the same. So for Drupal, it's going to have built-in functionality. For other platforms, you may need to get a plugin. And then if there's no pre-built plugin and it's not already built into your platform, then you can run it on Linux on your platform directly. So you can still run it that way. It's just the plugins and pre-built things make it a lot easier to manage. One performance tip just to mention is that you'd want to structure API requests to pull only recently modified data, and you'd use the last modified date rather than pulling all data. So rather than pulling the entire history of whatever piece of data you have, so our example of pulling all pets, we don't want all pets. That's like the entire 300 stores and all the pets they've ever sold. That's a tremendous number of pets. So we only want the ones that have really had any changes in the last day, for example. So you're just checking in the last 24 hours, any new pets or updates or anything you want to do that can be updated. So the last one here is going to be, we're looking at webhooks. So a webhook is a lightweight event-driven method for one application to send real-time messages to another application over HTTP. So unlike cron, the cron approach that repeatedly requests updates, which is called polling, this one here is going to use a webhook allows the server to push data immediately when an event occurs. So some event happens, and then in response to that event, a webhook is fired, carrying a JSON payload of information to its destination source or wherever you want to send the information. So in our example, when a new pet is created or updated, is when we'd apply this, and then by using a webhook, the pet manager system can inform the website that there's either a new pet or that there's an update such as it has been sold. So to set this up, on your website server, you'd create a custom endpoint to receive and process the data. So we need something to be able to handle the data. So as that webhook is received, we need to think of how are we going to handle that data? What do we want to do with it? And you build the logic of being able to handle that data that is being received. And then in Pet Manager, you'd register the URL to send the webhook to. So you're just basically going to say, now that I've built that endpoint, here's where I'm going to send that data to. And now you can send real-time updates from Pet Manager to your website, keeping your website up to date with what's going on in the other system. So let's dive into development. We've looked at our building blocks, we have our Legos, and now we get to apply those Legos and put them together to build something cool. Let's review the plan briefly. So we were going to use the iPaaS for core e-commerce integration. We're going to use, for the brick and mortar locations and services, we're going to use cron jobs to connect them to Pet Manager and pull in the needed data. For the product in-stock status and aisle, we're going to pull that into Pet Manager using cron on a 1-hour schedule. And then for the pet data, we're going to also use cron for that, but we're also going to blend that with webhooks to be able to pull that in. So these things that from a traditional mindset that were originally harder to like, how do I possibly do that based off of like the way you traditionally build a marketing website? Now that we're connecting to this pet manager using these building blocks, we can actually accomplish this goal. So let's go ahead and dive in. So step one is you set up the e-commerce and the integration. So you'd use your preferred e-commerce plugin and set up your store, and then you set up the iPaaS integration using their documentation to sync the following: products, inventory levels, customers, orders, and fulfillment. So on this one here, as I mentioned before, how you'd want to look at documentation and that's going to be a really valuable resource. Here, the documentation is going to be a really valuable resource of knowing how do you connect this thing, what are the steps to set it up, and they're going to give you basically a roadmap of how to get it set up for this particular scenario. So rather than diving in a lot here, the guides on how to do it, you've got a playbook of how to do it by just looking at the documentation that comes to the product that they're offering with that. And if it's a plugin for a product, if it's a plugin for something, that the same thing is true, that the plugin is going to provide the information that you'd want to be able to do. So now we dive into the custom stuff you'd have to do to fill in the gap of the other areas that aren't already handled. So you'd create a custom plugin, and you'd build a plugin to establish a connection with Pet Manager. So we'd start by looking at Pet Manager's documentation on how to connect, and we find out that it uses no auth 2 connection. It tells us the details of how to connect, and then we use AWS Secrets Manager or Secrets Manager on your hosting service to securely store the credentials, and then we build out the OAuth 2 connection, and then your API calls for cron will go into this plugin as well. So you're basically building this place to store all of your custom code for this connection, which is going to connect your website to Pet Manager. And then we're also going to create a cron run table to store API runs in with the last modified date. So for example, if we had a column that is job equal to location, with a row that would have locations, with a column that's last runtime that would store the last modified date. It's a very simple table, but this little table creates the foundation for what we're going to build in future steps with cron. So the first one we're going to dive into is doing locations. So with this one, we're going to create a custom content type to store the location data. By creating a custom content type, it puts it into the database, and it also creates it as a URL. So as new data is inserted, it goes immediately to a URL that can be published as a web page. You've got all the framework that is there, so all you got to do is publish the data into it, and it's already there for you. You've got a web page as soon as you publish the data. You may have a few other things to fill in manually, but the core data is already created just by creating a custom content type. You've created the structure. Now let's build the cron job to fill the data. So you write code to retrieve the data, the location data, along with services at that location, and update the content on the website on a regular schedule using cron. So we're going to start by using the cron run table, and we're going to pull the location. So where I said in the previous step there might be a column for job or jobs, you're going to pull, you're going to query the table for locations, and you're going to sort that by the last run date. So basically you're just looking for the locations job, what's the last run of the locations job. So once we know the last run, let's say that this job is going to run at 2 o'clock and it's 2 o'clock now. Our last run was at 1 o'clock, so it's going to pull up in the result that it's 1 o'clock. So I know that the last run was at 1 o'clock. So the next thing is I gave you some PHP code. There's a very few lines of PHP code to be able to put together a GET request. So all we're going to do is we're going to put together a GET request, and we're going to put into there just one parameter of the last modified date, that I want locations for anything that is greater than 1 o'clock. So anything that has been modified since 1 o'clock, give me that data. So that's what we're looking for. And then when we get a response, we're going to parse the response, and then we're going to use the IDs in that response to check if the content already exists in the database. So does that ID exist? And then if it doesn't, we either create or update based on that response. So you're going to fill in that content type of locations with the data from the response, and then you're going to save the run date time of the locations run in the database. So if this ran at 2 o'clock, you insert it in the database. So when it runs again at 3 o'clock, because it's running every hour, then it's going to know, oh, I ran last at 2, and it's going to keep updating the time as you go through. So that's the process we go through. All we're doing is every time it runs, we just store it in the database. Here's the last time I had a successful run. And then the next time I need to do a job, I just look when was the last successful run, and it keeps looping through. It's a self-sustaining process. So cron is a self-sustaining process as we do this. So let's look at some simple code of how we'd implement this. So the first few lines I've commented out, but basically all you're doing in this is just applying for your platform of choice. How would you apply this code? So I'm setting to a results variable a SQL query of the cron run table where job equals location sorted by the most recent date time with date time as the date time returned. So date time would be returned, and I want a limit of 1. I don't want all the jobs that have ever run. I just want, for this query, I want 1 result. And then if I do that query that way, then I can, in the next line, last runtime is equal to results last runtime. So if I pull that in there, the last runtime, I've gotten the last runtime. I also get the current date time, so before I do the run, before I make my GET request, I get the current time that I'm doing this. So I do this at the beginning and not at the end, because if you do it at the end, there could be a few second gap and now you're missing records. So you do it at the beginning. You set your URL, and you'll notice in this example, I've got a parameter, last modified, and oftentimes you'll notice that this one is underscore GTE greater than or equal. So that's usually a type of format that in a parameterized GET request, they can be less than or equal, but in this case, I'm looking for anything greater than this time frame. And then I'm going to take this time that I have in here, I'm going to URL encode it, and now I've got my URL, it's all prepared, and that URL is going to give me all the results from that URL of everything that's happened in the last hour. So now that I have my URL, I've got my API token, I set up the headers, I'm using accept because I want to get a JSON response. I open up my curl connection, and then I set the URL, and then I set the return transfer as true because I want a response back as a string, and then I set my headers as in the curl set options, and then I execute the request. In there I then get the HTTP code using curl get info, and then I close the session, and then I use JSON decode for the response, and I set that to data. And then if the HTTP code is 200, that means it was a successful response. I got the response I was expecting. And then I know that since I'm getting locations, this is going to be an array of locations. So if there's a result, so I'm doing data 0 because I want the first record in there, and I'm checking for ID. So if I've got a real piece of data in there, then I'm going to loop through that data. So in comments, I basically have what you'd fill in of how you'd work with that data. So I'm going to loop through it, inserting or updating based on whether the location already exists in the database. So in our example above, we had a content type. You're basically just looping through all the locations, and you're either creating new locations or you're updating locations. And this process can just run every hour and self-maintaining. If a new location is created, the website now has a new location. No human intervention is involved in making this. So where before we're like 300 pages, how do I build that? This is building all those pages for you. So you're keeping the data in sync with whatever's going on inside of Pet Manager, and it's just a self-sustaining process once we set up this cron job. And then at the end of this, I have in comments how you'd want to insert into the cron run table the date time of the current run, because once we've had a successful run, we've processed all the results successfully, then we save them to the database, and it'll keep running on the next job. So now that we've done locations, we're going to move on to the details by location. And this is for the in-stock status in which aisle things are in. And we're going to add a custom table to the database for location details that's going to store the fields location ID, product ID, stock status, and aisle. And then we're going to add code to the plugin just to pull this data and store it in cron. And basically on this one here, you're basically going to do this exact same thing as you did for the previous one. You're just going to use cron to pull the last run. You process the results, you get the results, and then you save it in the database. Here, what you do is, because you're saving in a table, when that page loads and you know, oh, it's the Chattanooga location of their store, you're just basically pulling in, I query the table for that, of those two parameters, and now I have the data for that location. And now you know, hey, for the Chattanooga location, it's an ILE, and you know exactly where to find the information. And then for the pet sync, you're basically doing the exact same thing. You're creating a custom content type for pets, and then you do some cron jobs to be able to pull the last run. You loop through the data, and then you save the result at the end. And now all your pets are self-maintained. You've got people using Pet Manager to be able to maintain the content there, and now everything's perfectly in sync when the pet is sold. The website's updated. So now you don't have manual intervention of a team of content editors maintaining that website. You've got Pet Manager people there are maintaining everything out of that system. And then we also want to be able to know the webhook. This one here is going to be a little different. So you'd want to be able to use the Pet Manager's API documentation for the format of the pet webhook. It'll tell you what data is available to send, what formats it's going to be sent in. Once you know that information, you can build a custom endpoint in your CMS. You'd want to look at your CMS's documentation on how you build a custom endpoint. It'll be a little bit different for each one. So you build a custom endpoint. Basically what you're looking for is you just want to make sure that as something hits that endpoint, you validate the request, make sure that it's from an authorized source. You parse the response for the ID, and then based on whether the ID exists or not, you would either create or update. And then in Pet Manager, you configure the webhook to just basically say, now that I've got that endpoint built, I want to send it to this URL. And once that's registered, every time that event occurs, those webhooks will be sent out, and your website will consume that webhook and process it for you. And then step 7 is we have a pet search. So for here, you'd create a search form with the desired filters that match up to the fields available on the pet content type. So whatever fields you wanted to use for filters, you put it on the pet content type. The search form would send a post command to the page with the body being in the form data, and then you'd write the PHP to handle it. I've got some sample code there of how you'd end up processing. It just basically creates the rough structure. So basically, if there's a post request, I just pull that information, and then once I know here's my data, I can then do whatever I want to with that data to be able to query the database for that data. So I'm sure you've built like a search form before, so that's how you do that. But once the pet data is in there, you can now query it and you can do searches for it. Congratulations. By applying those Lego blocks, we've built the website and applied all the and met all the requirements of the project, which, looking at the traditional mindset of marketing websites, would have been hard to do and a ton of manual labor. But now, by leveraging various API approaches, you've successfully met all requirements for the new website. Petmar is excited about how you built a site that maintains itself and provides up-to-date information to its customers. You can now launch the site and count it success. We've got like just a few minutes here. Are there any questions?
Pretty straightforward.
Yeah, it's pretty straightforward. So, thank you, everyone.
Are there any push capabilities in Drupal to allow a Drupal site to act as a data source for another Drupal site? Because I'm using Entity Sync on a project to keep two sites up to date with each other, and that's a pull process that has to be on a schedule.
Yeah.
And so there's a delay. Data gets changed on this site. There's a delay before it appears on this site.
Yeah.
Are you aware of any mechanisms to use a push technique instead of pull between two Drupal sites?
I don't have any good solutions off the top of my head for that, so it really is built into something that would already exist, and really, you'd have to have some trigger mechanism. So if a webhook already exists in your process, then you could
So
trigger
you
it.
build a webhook on the receiving side, and then you would fire some kind of thing on the hook from the sending side.
So to go back to that, so let me find the webhook. Let me find the webhook stack. Yeah, so for the webhook stack, so you start with the webhook API, and you're really looking at that system first. So your capabilities of what you do is based on what can trigger that event. And once you know that webhook's API and know here's the data that can be sent, here's what triggers the event, if you can get that figured out, then on the receiving side, in this scenario, it's the REST API that's in green, you'd be able to say, okay, now that I know what data can be sent at what triggers, you write something to receive that, to consume that data. So once you know what can cause the event, you can pretty much solve the receiving side by knowing that you're going to build the receiving side. So I don't have anything off the top of my head for that one, though.
Okay.
Yeah, sorry.
No, that's fine.
Yeah.
Are you asking how to create a JSON file?
Yeah, right. It would